Okay, so we're doing chapter 9, problem 69 here. And it says determine the center of mass of the machine part that is a uniform cone of height h and radius big R. Okay, so we have this figure here, and we're going to let the origin be the tip of the cone, as shown in the x, y, and z plane. And the cone is going to extend upward in the z direction. And from symmetry, automatically we should see here that the center of mass in the x and y positions are both 0. So we're only going to have to figure out the center of mass in the z direction. And we know that z center of mass is given by 1 over total mass integral of z little dm. Okay, so as the hint says, we're going to divide these up into little disks of a height dz and little radius r. So another thing we should write out here actually is the total mass can be written as just the integral of dm. So we can write now z as integral of z dm over integral of dm. We also know that this is completely uniform, which means we can express the mass component as a uniform density times the volume. So for a small chunk of volume, it's going to have a density such that dm equals rho dv. So now we have integral of z rho dv over integral of rho dv. Okay, so now we're going to go back to this diagram here and look at these disks. So for a small disk that has a radius r and a thickness dz, we have to figure out what volume this is going to have. Well, the volume of a disk right there is given as the area pi r squared times the height dz. So this is our dv. Okay. We can also see that based on the geometry of similar triangles, r over z is equal to big R over h. So that means that little r here is equal to z big R over h. So we can combine these and integrate. So z center mass component here is now given as rho, which we can pull out as a constant on both integrals, integral of z, oops, that was really bad, integral of z pi r squared dz over integral of pi r squared dz. Okay, so now that is where we plug in our r relation. So this becomes integral, these pi's are going to cancel. We have z times z big R over h squared dz over the integral of z r over h squared dz. Okay, so now we know these r over h squares are going to cancel out, and we're left with integral from 0 to h z cubed dz over integral from 0 to h z squared dz. So this just becomes h to the 4th over 4 over h to the cubed over 3, which is 3/4 h. This is our z center of mass, and that's the only component. So that means our x center of mass vector is given as 0 I hat plus 0 j hat plus 3/4 h. Oops, not j hat. That is a k hat. There we go.